Welcome to another tutorial on the action game system for Unity 3D. In this tutorial we will be creating another system, and in this system we will have a reactive state machine using Unity 5's mecanim state machine behaviors. This tutorial will be a little more advanced and it will probably take a little more time also, so I may have to split it into two videos, but we'll see. So let's start. I have prepared the example scene with a moving disk, and this could resemble some kind of a moving hazard in a game, and we will move this forwards and backwards using state machine behaviors, and also we will be creating a functionality that when the player steps on the pressure plate that we made in a previous tutorial, this moving disk should stop, and if the player steps off the pressure plate, the moving disk should continue as it was before it stopped. And yes, we will also be looking at the timer components of AGS. But yeah, we'll come to that. So let's start. I'm going to save a little time here by duplicating the pressure plate model and the pressure plate view, and we'll just rename them. So let's call this a moving disk, and of course a moving disk view. And we will have some compile errors here before we have changed the class names also. Oh, sorry. Moving disk. Moving disk, and also moving disk view. Moving disk view. And there are some docs here, so I'll just remove them for now, because I copied the pressure plate model and view, so this won't be correct. But never mind. We'll start with the model, and this model we'll need to create some kind of state and enumerator that will track in what state the moving disk is in. So let's start by creating this. A public enum. Let's call this what can we call it? A state direction. And this should be able to go forward, backward, and also none if the disk is not moving. State, I don't know, let's call it moving disk direction instead then. Moving disk direction. Moving disk direction. That's okay. And this is the pressured action property from the pressure plate, so we can just change the type of it here to a moving disk direction, and let's call it current direction. That is the actual value of the state machine at this point. And we can delete this copied function here. So we don't need a lot of methods on the model, but we do need a public void transition to state forward, and this will simply set the current direction to forward state. So current direction value equals to moving disk direction forward. And to save some time again, I'm going to copy paste this 2 times. We need to be able to go backward and backward, and we transition to state stop or something, and we say none here. And that's it for the model. I don't think we need anything else. So let's move on to the view. There's something wrong with it here. Oh, sorry. I accidentally renamed the initialize view method, but never mind. We're back again. So here we need a lot of properties. So I'll just write them down and explain while I type. So the first thing is we're going to need is an animator, because we are using mecanim for the state machine behaviors. So we need a private animator, and yeah, we need to be using Unity also. Unity engine. There we go. So we have an animator, and now we also need to declare some of the timer components that I mentioned before. So private timer persist. Oh yeah, sorry. I need to, of course, I need to be using the timer components namespace also. AGS cores, classes, timer components. And while I'm at it, I'll also be adding the extensions, mono extensions of AGS. AGS core, classes, mono extensions. So timer persistent game object. There we go. It's within the timer components namespace, and we can name this the forward countdown timer, and we'll copy paste this for the backwards countdown timer, backwards countdown timer, and then we need a float that actually counts down while the timer is running. So private float forward countdown, and I'll copy paste again to save some time. Backwards countdown, and yeah, I've forgotten the most important thing, that is the model. So we need also a public moving disk. And of course, oh yeah, there's the pressure plate. We don't need that. Instead, this is going to create a new moving disk. Oh. I'll be copy pasting a lot here to save some time. And these are also old code from the pressure plate view. Oh, sorry. There we go. So here we need to subscribe to the state of the state machine. So the moving disk current direction on value change. That's how we subscribe to the action properties. We get the sender and also we get the value, which in this case is the actual state. Yeah, we can do no. Yeah, let's write it like this so it's a bit more clear. We'll call a function within here instead of just writing the code right within the brackets. So on state changed, and here we'll send in the state as a parameter. The value. Oh, it sounds a bit stupid. And we can use OmniSharp to I thought we could, yeah, generate method again to save some time here. It looks a bit silly here, value.value, but let's do it instead. Right, current state, and we'll send in current state value as a parameter. And here's where we actually put mecanim in the right state. So we say animator dot set integer. This is how I usually do it, and we'll have a parameter on the mecanim animator controller, which we'll call the moving disk state also. And here we'll just say it's equal to, we cast the moving disk direction to an integer. Like that. And then we can go back to Unity and create this animator controller. Let's see if we have any compilers. No, we seem to be okay. So let's clean this up a bit. So we say moving disk and remove those model the model and view in there, and then we create another folder. Let's call it the state machine state. Okay, state machine, and here we create an animator controller, if I can find it there. So we call this moving disk controller, and let's implement it right away. We need this parameter that we wrote in the view. We called it moving disk state, which is an integer, and we need a state for each of the enumerator states. So we need none, and we need forward, and we need backwards. And then we simply go from any state to the correct state whenever moving disk state parameter changes. So we say, and this is important, you need to uncheck can transition to self, otherwise the transition will happen all the time while the condition is true. I never actually found a usage for when to use this checkbox, but never mind, as long as you untick it, it's okay. So oh yeah, I think we actually had none as the last enumerator integer, so that will be do's number 2. Can't speak English apparently. And this one is number 1, I think, equals to 1, and the forward state is equals to 0 then. Untick transition to self, and then moving disk state equals to 0. So this will be enough for now, or will it? No, while we're at it, we can just create state machine behaviors also. Let's start with forward state, and this is where you create behaviors. So I can just click here, and I'll type what I want to call it. So moving disk state forward, moving disk state forward, and here we'll do moving disk state backwards, moving disk state backward, create and add, and then we have to move them to the correct folder also. Where is it? System example moving disk, there we go, like that. There we go, and the none state doesn't need anything. In this state we will be just doing nothing. And yeah, I think I will stop this video and will continue in the next video. So bye for now.